Okay, so having realised that question 3 and 4 didn't work the first time, it didn't upload, I will just quickly show you and explain kind of what I've done for this. So with 3a, it's fairly sort of basic, expanding brackets and then collecting terms. So once you've expanded your brackets out, you collect your y terms together to get 13y, and you collect your numbers. Minus 6 plus 5 gives you minus 1. And then when you're doing the indices, you times the numbers together normally, so 5 times 7 gives you 35. And just a reminder that the laws of indices say that you add your indices here. Now I know that originally the u just said u. Just remember, because lots of people will leave that as u squared or u to the 2. If you've just got a u by itself, that's the same as u to the 1. So u squared and u to the 1 gives you u3. And then w to the 4 and w cubed gives you w to the 7. And then for question 4, when I first did this, I explained in detail the 2 different ways you could work it out. One, if you just focus on this top bit, this 45 and this 60, you can do it very quickly. This octagon on this side of the dashed line, this is the exterior angle of an octagon. So my working out is down here. The exterior angle of any shape adds up to 360. So I've done 360 divided by 8 because it's an octagon. The exterior angle of an octagon is 45 degrees. I've done the same with a hexagon. The exterior angles of any shape add up to 360. So 360 divided by 6 gives me 60 degrees. So if the exterior angle of an octagon is 45 and the exterior angle of a hexagon is 60, if I just add those together I get x, which is 105. I went on to show a different way of doing it. A reminder that every time you add a side to a shape, the interior angles go up by 180 degrees. So for an 8-sided shape, by the time you get up there, the interior angles add up to 1080. And if you divide that by 8, you get an interior angle of 135. And you get angles on a straight line, 135 and 45, that kind of makes sense. For a hexagon, using this, the angles in a 6-sided shape add up to 720. So to find an interior angle, I divide 720 by 6, which makes this 120. The interior angle of a regular hexagon is 120. And again, if you look, 120 and 60, they lie on a straight line, they add up to 180, so that kind of makes sense. So to find x now, I could individually use these interior angles, take them away from 180, get these 2 values and do it the same way as before. Or I can add these 2 interior angles together, which I've done over here, and then if I take that away from 360, because x and these 2 all together make a full circle, so if I add these 2 together, x must be whatever is left from a full circle, so whatever is left from 360. And again, if I do this sum, that again gives me 105. So not ideal because I had to kind of video it again, but there you go.